Hey everyone, so in this video we're going to review area of a sector. There is a video worksheet that goes along with this, so if you haven't printed out that worksheet you might want to do so. Okay, so area of a sector is a topic covered in geometry, but it's also a topic that comes up on the SAT as well. Alright, so it was definitely something that the geometry teachers decided they wanted to cover. Okay, so think of a sector of a circle like a piece of the circle's area. Okay, so if I was talking about a pizza pie, then a slice of pizza would be a sector of that pie. All right, so when we're trying to find area of a sector, we use the following proportion. All right, we compare the central angle to 360 degrees, because there's 360 degrees in a circle, and we set it equal to the area of the sector over the area of the entire circle. Okay, so we know area of a circle, we have a formula for that, it's pi r squared. Okay, so let's look at a few examples. All right, so again, throughout this lesson, we're going to be using this proportion. Okay, so number one says, what is the area of a sector of a circle with a radius of 8 inches and formed by a central angle that measures 60 degrees? Okay, so again, our proportion is always our central angle, so in this case, that's 60 degrees, over 360 equals the area of the sector, so since that's what we're trying to find, I'm going to call that x, over area of a circle, which is pi r squared. And in this case, our radius is 8. Okay, so I can clean up my proportion a little bit. We know that 8 squared is 64. All right, so that's the proportion that we're trying to solve, okay? So we're going to cross multiply. So we get 360x equals 60 times 64 is 3,840 pi. And then to get x by itself, we're going to divide by 360. All right, and then we can use our calculator to help us simplify that fraction. So if we do 3,840 divided by 360, all right, if we math frac that, we're going to get 32 pi over 3 is what that simplifies to. All right, so that is answer choice 3. Okay, so again, our proportion is the central angle always goes over 360 equals the area of the sector over area of the circle, which is pi r squared. Okay, let's try another one. Okay, so this one says, triangle FGH is inscribed in circle O. The length of OH is 6, and FH and OG are congruent. What is the area of the sector formed by angle FOH? Okay. So remember, in order to find the area of the sector formed by angle FOH, we need to know what that central angle is, okay? So we know that in a circle, all radii are congruent. So OG, OH, FO, all of those radii have to be the same length. So if all three segments in triangle FOH are congruent, we know that it's an equilateral triangle. So we know that this central angle right here has to measure 60 degrees. Okay, so now we can set up our proportion. So it's going to be 60 over 360 equals area of the sector, which is what we're trying to find, over pi r squared. Okay, so we get 60 over 360 equals x over 36 pi. All right, so if we cross multiply, we're going to get 360x equals 60 times 36 is 2,160. Then we divide both sides by 360 to get x by itself. Okay, so 2,160 divided by 360, that actually works out nicely. That's going to work out to be 6 pi. So that's answer choice 3. All right. Take a look at the third example. In the diagram below of circle O, the area of the shaded sector is 12 pi, and the length of OA is 6 inches. Determine and state the measure of angle AOC. Okay, so this one's a little bit different because in this one, they're asking us to find the central angle, and they actually give us the area of the shaded sector. So this time, my variable is going to be the central angle. So we're going to do x over 360 equals the area of the shaded sector, which they told us was 12 pi, over the area of the entire circle, which is pi r squared, or pi times 6 squared. Okay, so we get x over 360 equals 12 pi over 36 pi. All right, and what's nice here is that the pi's just cancel out since it's on top and bottom. So now if I cross multiply, I get 36x equals 360 times 12 is going to be 4,320. And then if we divide both sides by 36, we get x is 120. So that central angle is 120 degrees. Okay, last one, number 4. Cerise waters her lawn with a sprinkler that sprays water in a circular pattern at a distance of 15 feet from the sprinkler. The sprinkler head rotates through an angle of 300 degrees as shown by the shaded area in the accompanying diagram. What is the area of the lawn to the nearest square foot that receives water from this sprinkler? Okay. So they told us that this angle here is 300 degrees. All right, so again, we're going to set this up as a proportion. So we're going to do 300 over 360 equals the area of the sector, which is what we're trying to find, over pi times 15 squared. Okay, so we get 300 over 360 equals x over 225 pi. All right, so from there we're going to cross multiply. So if I cross multiply, I get 360x equals 300 times 225 is 67,500. And then to get x by itself, we're going to divide by 360. Okay, now in this example, they wanted the answer to the nearest square foot. So they don't want the answer in terms of pi. So we're going to have to go to our calculator. So we're going to type in 67,500 pi divided by 360. Okay, so to the nearest square foot, we're going to get 589. All right, so I hope that this was helpful in understanding area of a sector. All right, if you guys have any questions, you can always email me or send me a comment through Google Classroom. I will post a worksheet that has practice questions with an answer key, and then there will be a Google form for you guys to fill out. All right.